2016 number 3 is one of my favorite questions because if you know me, you know I'm a big crossword person. So I thought it was pretty neat that they had a question that involved crosswords. So there's kind of two parts to this question. In the first part, we're going to write a method to figure out which of these crossword squares get a label, and a label is a number. So you'll see just from looking at their examples, some squares have numbers, some don't. For a square to get a label, it has to meet this rule structure. It's got to be white, and it cannot have a white square immediately above it or immediately to its left, or both. And an extension of that is that any square that happens to be in the top row or far left column would get a label, because if it's in the far left column, it can't possibly have a white square to its left, and if it's in the top row, it can't have one above it. That's important because as we start writing this code, we're going to be in a two-dimensional array storage system, matrix. And if you go start searching for things above the top row or left of the left column, you'll potentially go out of bounds. So we'll probably want to make special cases for that top row and far left column. And the black and white squares are determined through a Boolean. So is black is true when we're talking about Booleans here. Okay, so anytime we go into the Boolean matrix later that belongs to this, if we get a square and we see true, then we know it's a black square. Okay, and then the number is the label. All right, so this class is just made up. A square is this encapsulated object of a Boolean and an int. Okay, a label as an int and a color as a Boolean. Might have other stuff too, but they didn't bother to tell us about it. All right, and they only shared the constructor. So later, when we're ready to make a square, we'll have to come back to this constructor. Okay, we have a matrix of squares, and it's called puzzle. A little peculiar in this problem. We're going to have to write the constructor. Usually that's the first thing you do. We're actually going to do that in part B, because to assist us with that constructor, they're giving us a helper method here called to be labeled, and then that will help us in our constructor later. Okay, so square at row R, column C is black if and only if black squares RC is true. All right, so they hand us a Boolean matrix. Okay, we're not going to look at the entire matrix, though. We're only going to look at one square. The one square that we look at is at a particular RC value. R and C are valid indexes, so there's no tricks here. They're not going to try to steer us out of bounds or anything. But we could go out of bounds if we start looking above the top row or left of the left column. Okay, so again, we'll have to kind of watch that. So all I really need to do to figure out if a square is labeled, which means I'll return true, is I need to go into the matrix. I need to first check if it's white. And if it is white, then I go on to check if it doesn't have a white square above it or a white square to its left. If it meets either of those criteria, then I'm going to return true. All right, so let's check out how we can write code to accomplish this. Okay. So we're in the crossword class, and like I said, it's a little peculiar that we're actually coming out of the constructor first. But so you could write a one-line answer here, just return. Okay, or if you'd like to structure it more like an if-else, that's fine also. So if we want to structure it like an if-else, okay, then the first thing you would want to do is go into black squares and verify that this is a white square. Now you could either say equals equals false, okay, or you could just put an exclamation point in front of it. All right, so that means that it's a white square. Now, in addition to that, it needs to either not have a white square above it or a white square below it. Remember, one way that could happen is if we're in the top row, okay, or if we're in the top column. I think you should probably check those first, right? Because think of how the short circuit could be to your advantage here. If we meet either of those criteria, we won't continue to read on within this if statement. But if we do keep reading on, then we would want to go above that row. and see if there's not a white square above it. So in other words, a black square. So we would go into the black square matrix now at row -1 with the same column, okay? And if we see true there, then that's black, okay? All right, and or we could go, oops, I forgot an S there. Okay, or we could go back to the black squares matrix, and this time we'll stay in the same row and we'll go one column to the left. All right, if any of those things turn out to be true, just all we need is one of those four, okay? Then we've met the criterion to label this square. So we're going to go ahead and return true, and that would shut this thing down. Otherwise, if we make it out of there, okay, then we're going to go ahead and return false. Now, let's think about this. Do we have a guaranteed return right now? Okay, so if we come into the if, we might return true, we might not. So this is weird, but you actually wouldn't want to like link the word else here. If you did, you'd have to come in and write else return false in here. The way we have it now, there is a guaranteed return. You gotta be a little careful here. If you actually linked the word else there, it could actually cause a little problem. So I think I put in a part A tester, but it looks like we gotta do part B because we need the constructor before we can worry about anything else. All right, so onto that constructor. Okay. Now we're going to try to go through and actually make this matrix. Now this matrix that we're going to construct is a matrix of squares. Okay, so it's not a matrix of Booleans like we saw in part A. It's a matrix of squares. We're writing the constructor. So remember, anytime you're writing a constructor, your first job is to initialize, okay, that instance field. And so that's the first thing I'm going to do is try to initialize the instance field puzzle. It's only been declared so far. So to be initialized, it needs to have a number of rows and a number of columns, right? That's the rule for a two-dimensional matrix. So the very first thing I would write here is that puzzle is a new, it's not a Boolean matrix, it's a square matrix. And its dimensions, if you read in the directions, are identical to the dimensions of black squares. So black squares has a length, okay, and we can pull up one of the rows of black squares. Row 0 would be the most logical, and take its length, and then we'll have the number of columns. All right, so now we have a puzzle matrix that's initialized, but right now every reference in puzzle would state null. Okay, so we're going to need to go into every single reference, and we're going to have to take the square from it, and we're going to have to initialize it with a new square. Okay, so the best way to do this probably is just go ahead and use indexed loops. Okay, and we'll walk across black squares. And well, actually, so you have an option here. I should point out you could also do puzzle.length. It shouldn't matter. Okay, they're the same. So there's my outside loop, and then I'll make an inside loop to handle all the column references. All right. And now what I'm going to do once I'm inside of here is I'm going to go to every single puzzle reference. So puzzle IJ, or I could have done RC, it doesn't really matter. And this is going to be a new square. All right, so now this is where it gets interesting. How do you make a square, right? Well, they told us that the constructor of square is expecting a Boolean and an int. And they tell us a little bit more about that here. And I think I reversed this here. So the Boolean, okay, comes down to whether or not this should be true or false. So true for black, false for white. How would we know? Well, remember that when we're writing code inside of the constructor, they're handing us a Boolean matrix with the same dimensions as puzzle. So corresponding values here, same row, same column. If they're true, then our square should have a true Boolean. And if it's false, then our square should have a false Boolean. Okay? Now, in addition to that, then some of the white squares go on to receive a label, okay? So the squares are labeled with a positive value, or they could get 0. So they didn't mention this until now. It's 0 if the square is not labeled. So that helper method we wrote in part A, if we call it and it says false, okay, there's 2 reasons it might say false. It might say false because the square is black. It might say false because the square is white, but it's one of the white squares that doesn't receive a label, okay? So if it is one of the white squares that doesn't receive a label, we're going to put 0. And we have to put something there. We have to put a number. So we're going to put 0. If it's a black square, it automatically gets 0 because no black squares are labeled. The remaining squares that do receive labels, notice that they're sequential, going in row major order, okay? So we'll need an additional variable to track that. So let's call it like label. Let's go ahead and initialize it to 1 because we don't want to label the first square with 1. So now this gets a little bit tricky here. It's probably not as easy as just saying new square. There's several different scenarios that I see. Okay, one scenario is, what if we have a black square? All right, so how would I know if I have a black square? Well, if I go into black squares and I go to ij, okay, and that comes back true, that means that I have a black square. And black squares, okay, they still go into the puzzle. They go in with a true, okay, and a 0 because they're guaranteed to not be labeled. All right, now, if it's not a black square, that means it's a white square, obviously. But even with white squares, they have 2 different scenarios, right? They either get labeled or they don't. So I need to call the method from part A. This is, again, if you read the directions carefully here, you would have seen, like, there's no dilemma on this, okay? They tell you got to call it to get full credit. If you're not using the method from part A, you're not going to get full credit. So I've got to call the method from part A, okay? The method from part A wants 3 things from me: a row and a column. Those are my loop indexes. And it wants a Boolean. All right, so it wants a Boolean matrix, I should say. So the Boolean matrix is black squares. Okay, they actually handed that to me, remember, right? So they handed it to me right here, and I can hand it right back to this method. This method comes back as a Boolean. Okay, so if it comes back true, then this means that I have a white square, and this white square is supposed to be labeled. Okay, so I need to say puzzle ij, and I need to put in here a new square. This square, however, gets false. That's my indicator for white, and it gets index. Now, you could go ahead and throw your plus plus there if you're comfortable with it. If not, then you're going to have to brace this if, okay? And the reason we're going to have to brace it is because we're going to have 2 operations in here. So let's go ahead and just brace it. And after we put that in, we're going to bump up the index so that the next square we make with a label would be 2, and then 3, and then 4, and so on. All right, now there's another scenario here, right? We could have a white square, okay, that doesn't get a label. Okay, so if we had a white square that was not being labeled, it's going to look just like this one. All right, the only difference is we're automatically going to put in 0 for the number. All right, that's pretty intense. Let's see what our crossword puzzle looks like here. And if everything works, it should match. Oh, sorry, I didn't call it index. I called it label. If everything matches, we should see the same puzzle created that was shown in the example. So like if you look at like these numbers, you see like this white 22. All right, if we go back to the top here where they showed us the puzzle, notice that there's a white 22 down there, okay? And you could check a few more of them. See like white 13 and 14 right there on the right. See that white 13, 14. See like these black squares here that looks kind of like a Tetris piece. So See right there, black, 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 and then one in the middle. Yeah, this looks perfect. You could go through and verify the rest on your own, but we've recreated this example. And if you look at my tester class, I handed it the same black squares matrix that they use. All right, so that's a pretty tough one there. That's a pretty big constructor. Okay, remember it all started right here. We had to first initialize that instance field, and then there was 3 different scenarios we had to handle. There's a black square, and then there's 2 types of white squares, and they all had different constructor scenarios. Okay.